Why do we need to really focus on the versatile test reactor now?
We're in a situation where we can't wait any longer for clean energy. We really need to have it now.
Energy demand is increasing drastically.
Whether it's for the electricity in your home, for heating, for refrigeration, for transport, for space exploration.
Another thing arising very quickly is the need for clean water. And cleaning water is a very energy-intensive process.
Quite frankly, we need to decarbonize our energy production. And there are not a whole lot of solutions out there that provide 24/7 carbon-free power.
There are limitations to wind and to solar. Most of that is because it's very difficult to store the energy.
There's only one technology that I can think of that can do so in a carbon-free manner, and that's nuclear.
With nuclear, you're providing zero emissions energy 24 hours a day. Less pollution, less illness, access to electricity, lower temperatures. If we really want zero emissions, nuclear has to be part of the answer.
Advanced nuclear especially really can be a great opportunity for decarbonizing not just the US, but also globally.
The beauty of the advanced reactors is that they're passively cooled, meaning that if for some reason the temperature started to go up above what it was supposed to be, the systems we have in place with natural convection cool the plant down again so that there's no potential for an accident.
You can attach them to a desalination plant and produce water. You can also use them to produce hydrogen, which can be used for a whole assortment of different processes. So there's really an opportunity for nuclear to not just focus on decarbonizing the electricity sector, but really branch out.
Many of them also operate with coolants other than water. They use liquid metal as the coolant, they use gas, they use molten salt, which means those new fuels need to be qualified.
Testing is a critical part of any technology. You need to have that test facility to actually simulate what you would really see in practice.
Is it going to degrade? Is it going to strengthen? Is it going to still transmit heat the same way? If you don't know how the material behaves, you can't put it into a system.
So the versatile test reactor can really be that user facility where companies can partner with the Department of Energy, partner with the national labs to test out some of the gaps that they wouldn't be able to prove otherwise.
We're on the precipice of change right now. We have our current nuclear fleet, which is shutting down because of economics.
Some have already come to the end of their lifetimes. Some are getting extended lifetimes, but we're talking not that far, maybe another 10, 15, 20 years.
So the question is there a timeline as it relates to implementing advanced reactors within our society? And the answer is the timeline is actually a decade ago. Other countries throughout the world are in fact investing proactively in nuclear technology.
And the US really needs to step up its game in order to compete with these countries.
We were the technology leader in the 70s and 80s, and we need the R&D infrastructure in this country for us to be able to step up again and say we are a serious player, and actually we are a leader.
Today, there are dozens of advanced nuclear companies here in the US that are interested in building some of these advanced reactors.
The only way that we can develop these reactors that consume waste, that are passively safe, that are able to achieve all of these great benefits, we need to be able to build a versatile test reactor.
We have the ability and we have the knowledge, we have the mindset to develop a piece of infrastructure that can facilitate this in the US. It doesn't make sense not to do it.
VTR, solving energy challenges through science.